Very tasty integrals today. We've got the square root of the integral is equal to the integral of the square root of some function on both sides. So what we'll do, we'll start off by saying that our f of x is equal to some derivative squared. We do squared so that the square root on the right will cancel out. Let's stick this thing in. What do we get? Well, we'll have the integral of this thing squared, the dy dx squared, all square rooted still on the left. On the right then, we'll just have the integral of dy dx with respect to x. So we can evaluate this thing on the right. It's going to be just y plus some constant which we'll call c. And now then, we'll square both sides. So we're going to have the integral of dy dx squared with respect to x is equal to y plus c all squared. And now we will differentiate both sides. So the left, we're going to have our dy dx squared. And on the right then, we'll get 2 lots of y plus c, plus the differential of the bracket, so dy dx. And what we'll do now is we'll bring everything to the left-hand side and treat it almost like a quadratic. So we'll have dy dx, we can actually factor that one out, multiplied by dy dx minus 2 lots of y plus c. And this whole thing equals 0. So we get the solution that dy dx equals to 0. That's one of our things. So technically y is equal to c, but we don't really care about that because we think about what we want is f of x. So we just square this and we get 0. So one of our solutions is f of x is equal to 0, which kind of makes sense. If you have the integral of 0, the integral of 0. Doesn't really matter if you square root it, it's just going to be a constant equals a constant. The interesting one there comes from this square bracket. So what we have, dy dx, we can take this 2y plus c to the right as well. So 2 lots of y plus c. So for this thing then, we will do separation of variables. We'll bring the y plus c to the bottom of the left. So we'll have dy on y plus c. We'll leave the 2 on the right and bring the dx over there. So 2 dx. Now integrating both sides. The left, that will give us the natural log of y plus c. And the right will be 2x. We'll have another constant, we'll call that k, not to mix up with the other c. And now then, if we take both sides to the power of e, so using the kind of the definition of logs, we'll have y plus c is equal to e to the 2x plus k, and that e to the k we can just call a. So a e to the 2x. So y is going to be equal to a e to the 2x minus c, and now we want to differentiate that thing. So dy dx is going to be equal to 2a e to the 2x. And now what we want to do, we want f of x, so we'll square that. So f of x is going to be equal to 4a squared e to the 4x.